So we've been learning about composition of functions, and composition of functions is kind of, it's obviously important and useful in its own right, but it is also a prerequisite subject before we talk about another important topic, which is inverse functions. Now, inverse functions is really a really important thing for us to discuss before we move to our next major subject in this class, which is exponential functions and logarithmic functions. But I want to stress that this subject, inverse function, is not specific to exponential and log functions. Inverse functions are used for all different types of functions. And so in this section, we're going to be doing it with like polynomial and power functions. And then we're going to do it with exponential and log functions next. And then later in the semester, we're going to do it with trigonometric functions. So this is a function concept which spans like the whole class. So let's say you've got a function, it's got an input, x, and then you go into this f, and then its output, we're going to call it y. So output. The idea of an inverse function kind of comes down to saying that we're going to swap the input and the output. So we're going to now relabel this and talk about the output being x and the input being y, and the arrows are going to turn around. So it's going to go like that. So instead of inputting x and getting y out the other side, now we're going to take y, put it in, and get x out the other side. And this function that does the opposite, whatever f does, this function undoes it. This function is called f inverse, and the notation for that is f with a little superscript -1. Normally, warning, normally that means, normally like a -1 power means to reciprocate something, right? Like x to the -1 means 1 over x, but this is not the same thing. We're borrowing this notation from the reciprocal situation to mean the inverse of a function, which is a little bit different. So think of that in this context on a function name like f, that means inverse. It's not a -1 power. Okay, so let's do a little example. Let's say you have f of x equals x cubed. So in this situation, you input a number like, let's say you input 2, then the output would be 2 cubed, which would be 8, right? So if we invert that and if we think about the inverse, then it would be the thing that undoes the cubing, right? Instead of giving an input of 2, now we're going to come up with a function that can give an input 8 and then produce the output 2. So what would that function be? It's going to be called f inverse, and we write it f inverse of x. So the f -1 is the name of the function, and then of x, just like how you'd write f of x. But what would it be? It'd be the thing that undoes cubing. Well, that's a cube root, isn't it? So this is f, x cubed is f, and and the cube root of x would be f inverse for that example. So one of the important things about inverses is this property that when you compose them together, function composition, they cancel each other out. If you do f of f inverse of x, you get x right back again. Because think about what happens. You take your x, you put it into, in this order, you take x, you put it into f inverse. I should have actually written it in the other order. For the sake of this explanation, let's write it in the other order. The other order, f inverse of f of x. So what happens in this situation is you take your x, you put it into the f function. Okay, look back up here. X goes into f and it gives us y, right? And then you take that and you stick that into the f inverse function. And then it's going to give you y goes into f inverse and it gives you x right back again, right? So when you compose these together, f inverse composed with f x goes in and x comes out, which means it essentially does nothing. This is like they cancel each other out, and this is called the identity function. Okay, it's a function. It results. Actually, sometimes it's called I, like capital I, and it's the function that does nothing. It just you put it in and then you take it back out, and it didn't do anything, right? Whatever the inputs are the outputs as well. So function inverses, the whole idea of the function inverses is they undo each other. Whatever f does, f undoes, and when you combine them, they cancel each other out. So in this example, if we were to do cube root of x cubed, you get x back, right? Because the cube root and the cube cancel each other out. And it works the other way. Like, I wrote it in f inverse f of x. First I had it the other way around, right? And for the notation, for the particular like x and y inputs and outputs, I wanted it this way. But it works if you compose it in the other order as well. So like in this example, if you start with the cube root of x and then you cube that, so you take that and you stick that inside the cube function, those still cancel each other and you get x back. Okay? So there's at least an introduction to what an inverse is.